The James Webb Space Telescope, JWST, project promised the most detailed and sharpest infrared photographs of far-off galaxies, peering into the past to help solve puzzles regarding the universe's beginnings. After traveling over 1 million miles from Earth and spending months getting ready to collect data from the outer regions of space, the telescope has already begun transmitting full-color photographs to NASA. By allowing us to see stars and galaxies as they were 13 billion years ago, the telescope allows us to look deeper into space than ever before. Since then, the transformational NASA project has produced a consistent supply of breathtaking pictures. The JWST just recently released sharp and detailed images that are mind-blowing. Of course, the JWST isn't only there to blow our minds. According to NASA experts, its work will be important for understanding both the universe as it is now and its early history. What new information and data do we have from the JWST and the Hubble Space Telescope? Let's find out. The James Webb Space Telescope, which is already well known for its captivating photographs of the cosmos, has succeeded once more with its first image of Neptune. NASA's James Webb Space Telescope displays its capabilities closer to home. In addition to providing the best glimpse of the planet's rings in more than 30 years, Webb's cameras also shed new insights on the ice giant. The clarity of the planet's rings, some of which have not been seen since NASA's Voyager 2 became the first spacecraft to examine Neptune during its approach in 1989, is what stands out most in Webb's latest photograph. The Webb image vividly displays Neptune's fainter dust bands in addition to many brilliant narrow rings. According to Heidi Hamel, a Neptune system specialist and transdisciplinary scientist at Webb, it has been 3 decades since we last observed these faint, dusty rings, and this is the first time we have seen them in the infrared. These incredibly weak rings were discovered so close to Neptune thanks to Webb's exceptionally consistent and accurate image quality. Since it was discovered in 1846, Neptune has captivated scientists. Neptune orbits in the distant, dark area of the outer solar system, 30 times further from the Sun than Earth. High noon on Neptune is comparable to deep twilight on Earth because of how small and pale the Sun appears from such a great distance away. The internal chemical composition of this planet qualifies it as an ice giant. Neptune is substantially richer in elements heavier than hydrogen and helium than the gas giants Jupiter and Saturn. Small concentrations of gaseous methane enable Neptune to appear characteristically blue in Hubble Space Telescope photos at visible wavelengths, which is easily observable. Neptune does not seem blue to Webb because its near-infrared camera, NIRCam, only sees objects in the near-infrared spectrum between 0.6 and 5 microns. In fact, the planet is fairly black at these near-infrared wavelengths due to the substantial absorption of red and infrared light by methane gas, with the exception of areas with high-altitude clouds. These bright streaks and spots of methane ice clouds are noticeable because they reflect sunlight before it is absorbed by methane gas. Over the years, images from other observatories such as the W.M. Keck Observatory and the Hubble Space Telescope have captured these rapidly changing cloud features. A more discrete visual indicator of the worldwide atmospheric circulation that fuels Neptune's winds and storms could be a thin line of brightness circling the planet's equator. At the equator, the atmosphere lowers and warms, making it lighter in infrared wavelengths more than the nearby cooler gases. Neptune's northern pole near the top of this image is just out of sight for astronomers due to its 164-year orbit, but the Webb images suggest an unusual brightness there. Webb's image clearly shows a previously known vortex around the southern pole, but this is the first time Webb has shown a continuous band of high-latitude clouds surrounding it. 7 of the 14 known moons of Neptune were also discovered by Webb. A very brilliant point of light with the distinctive diffraction spikes observed in many of Webb's photographs dominates this Webb painting of Neptune. However, this object is not a star. This is Triton, the big and strange moon of Neptune. Triton reflects about 70% of the sunlight that it receives thanks to a frozen coating of condensed nitrogen covering it. Because methane absorbs at these near-infrared wavelengths, it outshines Neptune by a significant margin in this photograph. Triton's peculiar retrograde orbit around Neptune has led astronomers to hypothesize that this moon was once a Kuiper belt object that was gravitationally grabbed by Neptune. Additionally, The James Webb Space Telescope has taken its first pictures of Mars by sensitively observing infrared light originating from the planet. On September 19th at the Europlanet Science Congress, EPSC, 2022, the first photos and spectra of Mars from the James Webb Space Telescope were made public. On September 5, 2022, JWST took the pictures and measurements from its approximate million-mile, 1.6 million kilometer, distance from Mars. The images of Mars's observable disk, or the side of the planet facing the telescope that is illuminated by the sun, were taken by Webb's near-infrared camera, NIRCam. They could offer planetary scientists a distinctive perspective of Earth's close neighbor and deliver data that can be used in conjunction with observations made by rovers like NASA's Perseverance and objects in the Martian orbit. It is not the simplest object for the JWST, which is designed to observe extremely distant and dim objects, to see because Mars is relatively close and highly bright. Astronomers can study short-term phenomena like Martian weather patterns, dust storms, and even changes brought on by the planet's seasons thanks to the JWST's ability to take images and spectra with the spatial resolution they require. The Webb telescope also allowed for simultaneous observation of events that take place throughout the Martian day, including during the day, sunset, and night. The eastern hemisphere of Mars is depicted in two different wavelengths of light in the JWST's initial photos of the planet. Reflected sunlight dominates the short wavelength image, which depicts elements of the Martian terrain that mimic those observed in visible light. These features include the Syrtis Major Planum's dark volcanic rock and the 280-mile-wide, 450-kilometer-wide, impact crater Hellas. The light that Mars releases at longer infrared wavelengths as it loses heat was captured by the NIRCam camera on the Webb satellite telescope. The brightest and warmest region of this light is seen where the sun is practically directly overhead the planet and is correlated to the temperature of Mars and its atmosphere. The brightness decreases in the northern hemisphere of the planet, which is currently experiencing Martian winter, and in the polar regions of Mars that receive less sunlight. However, the amount of light that reaches the JWST is not solely dependent on the planet's temperature. The chemical makeup of the Martian atmosphere and surface can also be inferred from the telescope's photos. Astronomers may be able to learn more about Mars's atmosphere and surface by using data from the James Webb Space Telescope to analyze the spectrum of light that was identified coming from the planet. During the warmest part of the Martian day, the 1,200-mile, 1,930-kilometer, Hellas Basin seems darker than its surroundings according to an analysis of the JWST photos. This impact structure's apparent darkening is the result of light entering the Martian atmosphere and being absorbed by carbon dioxide. The new photographs also show how the James Webb Space Telescope may investigate Mars using measurements made with the telescope's near-infrared spectrograph (NIR-SPEC) instruments. A method known as spectroscopy allows planetary scientists to analyze the fingerprints that different chemicals leave in the light flowing from a planet's atmosphere to establish its composition. Since chemical elements absorb and emit light at very particular wavelengths, the scientists' initial findings reveal spectral patterns that are encoded with details about Martian dust, frozen clouds, all of which make up the atmosphere, and the kinds of minerals that can be found on the planet's surface. Water, carbon dioxide, carbon monoxide, and other chemical components should be detectable by JWST observations. Methane is significant because it can inform planetary scientists about a variety of geological processes occurring on Mars, including whether or not a significant object has recently struck the red planet from space. Methane may also provide evidence of past biological activity on the planet. The first clear indication of carbon dioxide in an extrasolar planet's atmosphere has also been recorded by the Webb telescope. The discovery not only offers intriguing clues as to how the exoplanet developed, but it also serves as a preview of what to expect when Webb investigates more and more extraterrestrial planets. The discoveries are shown in a data plot that lacks the brilliance of Webb's earlier photos, which featured galaxies caught in a cosmic dance and dazzling clouds in a star nursery. However, the data are beautiful according to Jesse Christensen, an astronomer at the NASA Exoplanet Science Institute at the California Institute of Technology in Pasadena. The exoplanet WASP-39b is known as a hot Jupiter by scientists because it has a diameter similar to Jupiter but orbits its star much more closely than Mercury orbits the Sun, making it extremely hot. The plot, or spectrum, provides detailed information about the atmosphere of the exoplanet. The planet, which is more than 200 parsecs away from Earth, was first spotted through ground-based studies in 2003, and it was later found by NASA's Spitzer Space Telescope, which was operational from 2003 to 2020. Although the latter's data were inconclusive, they did raise the possibility that WSP-39b's atmosphere contains carbon dioxide. Webb then came into the picture. On July 10th, the infrared telescope tracked the planet as it moved across the face of its star for a little over 8 hours. During this period, sunlight penetrated the atmosphere of the planet and was absorbed by distinct molecules at particular infrared light wavelengths. Scientists questioned whether carbon dioxide would manifest itself as a visible blip in the spectrum. Natalie Batalha, an astronomer at the University of California, Santa Cruz, UCSC, and the team leader for Webb's Transiting Exoplanet Early Release Science, says, and there it was, just jumping off the computer screen. The outcomes increased confidence that Webb will be a game-changer for exoplanet research. The telescope is ordered to observe 76 exoplanets in its first year of operation alone. The total might reach hundreds throughout the course of its lifetime. It will peer through the atmospheres of small, potentially Earth-like rocky worlds and gas giants. Finding carbon dioxide, though, is impressive in and of itself. One may reasonably anticipate that a planet like Jupiter, which sprang from the same disk of matter as its star, would share the star's chemical composition. For WSP-39b nor for our solar system is it the case. Strong carbon dioxide signals from the exoplanet indicate that it is loaded with elements heavier than the hydrogen and helium that normally make up stars. Why is the issue at hand? The narrative then begins to pick up steam. It's probable that comets and asteroids hit WSP-39b when it was young, delivering heavier elements like carbon and oxygen. It's interesting to note that the exoplanet appears to contain the same quantity of heavy elements as Saturn, which astronomers believe likewise had a turbulent youth. Alternatively, it's possible that WSP-39b evolved from elements in the icy outer limits of its planetary system before moving inward when it reached its ultimate resting place. It was close to its host star, which may have blasted away part of the hydrogen from the exoplanet's atmosphere, concentrating the heavier elements and enriching them with carbon dioxide. For articles that will examine these possibilities and analyze the planet's spectrum in a lot more depth are now under development by scientists. Finding carbon dioxide in a planet's atmosphere is the first step in finding life outside of Earth. WSP-39b is considered too close to its star for it to support life, according to astronomers who also do not anticipate it. They don't even anticipate the Webb telescope to discover undeniable evidence of extraterrestrial life. Carbon dioxide and methane in a planet's atmosphere are thought to be signs of life, according to astronomers. In the end, finding life will probably call for an observatory considerably more sophisticated than Webb, but for us to be prepared for that technology in the future, we must get through this incredibly crucial era. On the other hand, the Hubble Space Telescope has made a significant advancement in its quest to determine the rate at which the universe is expanding, which is consistent with the notion that something weird is going on in the cosmos. Astronomers have recently utilized telescopes like Hubble to precisely measure how quickly the cosmos is expanding, but as those measurements have improved in accuracy, they have also revealed an oddity when compared to observations made just after the Big Bang. There is a significant difference in the rates of the universe's expansion. As it is now, that disparity is beyond the comprehension of scientists, but it implies that something unusual is happening in our cosmos, which might be the product of brand new undiscovered physics. For the past 30 years, Hubble has been accumulating data on a collection of milepost markers in space and time, which can be used to monitor the speed of the universe's expansion as it gets farther and further away from Earth. According to NASA, it has now calibrated more than 40 of the markers, enabling even more precision. The Nobel Prize winner Adam Rees of the Space Telescope Science Institute, SKY, in the Johns Hopkins University in Baltimore, Maryland, said in a statement, "You are getting the most accurate measure of the expansion rate of the universe from the gold standard of telescopes and cosmic mile markers." When American astronomer Edwin Hubble saw that galaxies outside of our own looked to be moving away from us and doing so faster the further away they are from us, the search for a precise estimate of how quickly space was expanding began. Since then, scientists have been looking for a better explanation of that growth. This is a time of great discoveries, and we are here for all of them. Thanks for watching another episode. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.